Alright, so in this problem we're looking at writing a formation reaction for liquid propanol, and we have an associated standard enthalpy of formation, delta H naught F, available to use to denote that. And a further step to this problem, which we're not doing here, but would be you could then, once we write it and we have that delta H associated, you could then do stoichiometry with it and figure out how much heat was evolved or created or absorbed based on looking at the amount of grams or milliliters or some other measure of the substance that you used or made. Okay, so here's how we're going to do that. The first thing we need to do is remember what propanol is. So propanol, 3 carbons. Propane would just be C3H8, but because it's got the propanol, that refers to an alcohol. So what we're going to be forming here is C3H7OH. We know that that's going to be a liquid. Okay, as I like to refer to it, usually when I make it, I will just say it forms a C3H8, and then just take off one of the H's and add an OH for an alcohol. Okay, so we know we're going to need carbon. So carbon, its most stable state at 25 degrees Celsius, is in graphite form. So we're going to be adding graphite. Okay, we know we need hydrogen, so this is going to come in the form of H2 gas. And we know that we're going to need oxygen, which at 25 degrees Celsius will come in its most stable state as O2 gas as well. So now all we need to do is go ahead and balance it. So we need 1 oxygen, we have O2, this is going to be 1/2. For the hydrogen, we need 7 from the first part and then 1 more, 8, so we're going to have 4 hydrogen gases will balance that, and then we need 3 carbons. So this right now is the formation reaction of propanol. Okay, and now I'm just going to make a little bit of room. If we write this out as we would a regular reaction, we would now put next to it the delta H formation, since this is a formation reaction, is going to be negative 303 kilojoules per mole as written. So in order to make 1 mole of propanol from its elements in their most stable states, it evolves 303 kilojoules of heat. Okay, so that's how we write out a formation reaction. And from this, again, if you had some number of grams of propanol or somehow to get to moles of propanol that were made, you could use this delta H naught of F and calculate exactly how many kilojoules were released on the basis of forming that much. Okay, you can also use this reaction in Hess's law, as we've done with some various reactions like this, in order to calculate a different formation reaction.